All right, Tony, you should be good.
All right, thanks a bunch. Okay, so good morning. Again, this is Tony Bailey, State Conservation Agronomist with NRCS. Happy fall. It's not very often that the weather actually matches the season on the calendar, especially the first day. So anyways, today we'll be we'll be presenting on the pesticide management and water quality implications, number 6. And as we mentioned, you'll receive credit for this related to AgLearn. As we've already had our assistant, Stephanie McLean, will be moderator, and appreciate her helping me out on this. So as we get started, several things to think about for today. And, you know, we always have, whether it's an agenda or whatever else, but I just thought these would be some things for you to keep in the back of your mind. How do pesticides impact water quality? We know pesticides are used agriculturally and a variety of other situations. How can they be used more effectively? What can we do to improve that? Also, how can or should we encourage improved understanding of integrated pest management, IPM, and pest management plans, PMPs, to make seasonal, yearly tweaks and improvements? And then what are the impacts of healthier soils and more wild areas on pests and pesticide use? And so the beneficials that are there and all of that. So we'll hit on all these things here a little bit as we go on today, but just some things to keep in the back of our minds as we go through. So whenever we start thinking about all this in context, I just have to, for myself, step back a little bit and think about it as agricultural production. You know, we have this concern that we need to produce more, and yet what are some of those challenges? And hopefully you've already thought about a few of those. I see some of the challenges as the number of mouths to feed, you know, what our predictions are, population trends. We also have our land use and productivity. Will we continue to expand cities, add subdivisions, add strip malls, bypass to the bypass, you know, I-69 type projects in some of our most productive farmland in some cases, or splitting farms in two. So those things all kind of come into play. Where do our nutrients come from? How much energy does it take to produce them? Are we running short on those resources? Just keeping all that in mind, we still need those nutrients to be able to produce these crops. How is the climate, extreme weather events impacting this, whether it's a drought or flooding, whether it's the movement of materials that we need for the fertilizer or whatever else? All that comes into play, and then how that production is also being used with energy and biomass. You know, just because we want to switch to more biodiesel or ethanol doesn't mean that that's necessarily carbon neutral, especially if we're pulling in more sensitive land. We need to pull more sensitive land in because some of the best, most productive land we've put houses or factories on. So all those different challenges are there, kind of in the background for us to think about. I think about those production things. I always think about the yield limiting factors. And so we're always hoping that the farmers are trying to do what they can to address those areas, and in those low yielding areas, trying to repair them, or we need to put them into some other use. And I think in some cases, if we already have it in agriculture, there's some things that we can do agronomically. And you know, we've got these the genetics. Nutrients, we can try and overcome the pH and fertilization issues. Addressing the pests, drainage is always a factor, but some of those things I think are exacerbated as we've degraded our soils. You know, if all we've done is compacted our soils, created more, caused more problems with infiltration, lost soil through erosion, loss of soil organic matter. All those things impact yield limiting. If we've got 100 bushel bean potential in the genetics, and we're hitting 50 bushels, 55, 60, we're leaving 40% on the table, and we're missing out on that. Now, sometimes soil is obviously our limiting factor, but what are these other pieces, these other factors that can be addressed? And I think most of us are thinking about how that soil till, soil quality, soil health comes into play on more of this, so that we have maintain and increase yield productions. Start thinking about watersheds, water quality related to that, all the various practices, but then with that, all the various loss mechanisms, potential, and whether it's sediments or nutrients, pesticides, all those different conservation practices, management activities that we can do to protect that. And I really like this depiction here, one of my favorites, especially because it has the soil health as the base of the pyramid. But one of the things I don't see mentioned on here is pesticides. And at the same time, we know that the use of the pesticides is going to happen, but will impact those other practices that we're going to use. And so we need to figure out how all these work together and fit together better. So with that, just a little bit of background, a little bit of intro. So let's think a little bit about pest management, water quality specifically. So how can pest management impact water quality? When we talk about pest management, we're thinking about a variety of different ways that we can manage those different pests. And so a lot of times, if it's weeds, we're going to be thinking about some sort of mechanical control, tillage or cultivation. That moving the, not being in corn, or a lot of times the disease specialists will tell us there's too much residue on the surface. We need to get rid of that residue. So whenever we do that, we increase the potential for sediment risk, obviously. We're also going to use those products, those chemicals, and anytime we use them, that also puts out a potential risk factor for that. When we think about pesticides, just want to remember that it covers a variety of different things. I know every now and then we get a little confused. We start throwing the term pesticides, and we think that's a specific piece of this, but that covers the overall broad picture of this. And so that's the herbicides, insecticides, and fungicides, and then some of these other things that we don't get involved with as much as those first three. As I mentioned, we are going to use pesticides, but using them, they have a toxicity, and we want them to have a toxicity, but we want that toxicity to be directed towards the pests that they're being applied for. That's the target. That's what we want them to control. Unfortunately, usually anytime we use them, they're also non-target species in those application areas. And then probably even more of a concern is what happens on those non-target species beyond that application area, and especially when we start thinking about runoff and aquatics, but then also our fringe wildlife areas. How do those pesticides impact all of those? And then also, if we're using that drinking water, we have pesticides in it, is it having to be treated? It's able to be treated, but it's more expensive, takes more time, costs more, and all that's passed on to the end consumer. So we think about those pesticide impacts. We think about it in our context, how we look at it from resource concerns, planning criteria standpoints. We think about it from aquatic habitat concerns. Again, that runoff, the impacts on invertebrates, the fish feeding on them, those food sources of plants that are out there, how those products move off site, how they get to where they're going. And we'll talk more about how we try and break some of that up and how we try and control that a little bit. Those drinking water concerns, Again, I don't hear about this as much as we used to, which is a good thing. Not quite sure why that is. If we're doing that much better job, probably a combination of switch to some different products we don't use as some of the products that we're having challenges with in the past. So one of those products that we use in the past a lot, I think we still use it a lot today, Atrazine. A couple little charts here from late 1990s, early 2000. So it shows the atrazine use. Atrazine is used pretty much where corn was produced at the time. That picture on the left, shows the atrazine in agricultural streams. And as you can see, where we use it at, unfortunately, it's over the high threshold in a lot of the streams. But that's also an area where a lot of the runoff was occurring. Look over at the picture on the right, atrazine in shallow groundwater. And so in that case, you start looking at some of those red circles, and we start seeing some sandier places. I'm guessing Wisconsin, probably the Delmarva and places like that. Maybe some other with shallower wells, shallower groundwater. So where we're using it at, obviously, if we're using it, we have higher potential for it to move, to get into the water, and then depends on the soils, the backgrounds, and different things, and we'll touch on a lot of that as we move along here. So we make that initial pesticide application, and there's a lot of different things that can happen to that product once it's applied, once it's out in the environment. How long is it going to hang around? What's its half-life? What happens with that product once it's applied? Is it water soluble? Has it potential to move off site? Does it attach to the soil particle? And then we also have these other environmental factors. What's the pH of the soil texture? What's the temperature out? And do we have a lot of sunlight at the time? Is organic matter 1% or 4%? The biology a little bit in the soil starts to make some difference. What impact in the half-life? The moisture, is it wet? Is it dry? Do we have a lot of rainfall right after that? So all these things start to come into play on how that pesticide reacts. And when we want it to react wherever we're applying it and whatever we're trying to control, obviously. So that's why we have some of these challenges. And then the environmental fate of it, kind of comes into play if it moves through the system or isn't absorbed to the soil, or then we've got it moving away. Another kind of way to think about that chemical fate process, make those additional, original application. We want it to be applied to the plant or taken up in the plant. But then those other processes start to impact it, the volatilization, the photodegradation of that. We can also have various erosion. If we've got a lot of wind, we can move the product off site. We can move it in runoff. And then also, if it absorbs to the soil particles, or whether it goes through some sort of chemical or microbial degradation. And we're hoping that, again, it's being taken up and utilized where we want it. Unfortunately, in almost all cases, there's some that escapes and moves into the environment. We're hoping that this piece down here, this microbial or chemical degradation, that there's enough biology in the soil that it is able to neutralize a lot of it before it moves off site and causes other issues, whether it's leaching or runoff. Also, with the different products that we use, we have different hazards related to them. So in this case, looking at atrazine, metolachlor, glyphosate. All three products, they have different loss potentials and toxicity and hazards. So in that first bar graph on the left, that loss potential of metolachlor is very high, has high potential to be lost. Look at the toxicity though. It's not as toxic as the atrazine. And then by the time we combine all of those, the actual hazard potential for the atrazine is much higher than the tolachlor and the glyphosate. So trying to think about all these in context, the different products, how they respond in the environment, but also the toxicity potential of that gives us our hazards. So start thinking about the pest management risks to water quality. So and I guess that's one of the things we've been challenged with a little bit when we start thinking about pesticides. You know, they have a label. EPA regulates them nationally with a pesticide registration. They're required to follow the label. There are specific environmental conditions related to different pesticides like soil texture, as well as sometimes very specific mitigation requirements for those pesticides, and whether that's here in Indiana or other parts of the country. But that's all labeled nationally through EPA. At the same time, significant risks still exist, especially when we start thinking about various sensitive areas. And sometimes those are listed there and sometimes they're not. So by contrast, you know, we think about this from a field level, identifying those site-specific resource concerns, including water quality. So specifically, and we'll just talk a little bit about groundwater. If we've identified that as a resource concern for the land unit being evaluated, what are the characteristics of the recharge area? Is it a high percent of agriculture? Is it in soils with a lot of runoff, or the soil sandy? And so we want to think about all of that. And also, what's at the bottom of the root zone? Is it a confined aquifer? Is it a bedrock unconfined? Is it, of course, sandy, or is it something completely different than that? And then what are the additional groundwater aquifer characteristics? How old is it? How much water is moving into it? How much water is moving through it? And then what is that groundwater used for? You know, there's times where you know, we're drawing on you know, as far as well water, a small number of users, and other times we have a lot of users pulling on that groundwater. Or it could be kind of surface water, and thinking about that as a resource concern for the planning land unit being evaluated. And again, what are those watershed characteristics? What percent of it is in agriculture? What are those soil characteristics? How much runoff do we have? How much infiltration do we have? Weather events, weather patterns. What are the surface water body characteristics? Are we working with an impounded lake? Is it a free-flowing stream? What are the sizes of those? How much water moves through them? How quickly does it move through them? All come into play and make a difference with that. And also, what are the flow, the overland flow characteristics for that surface water body, between the surface water body and the planting unit? So those are things such as distance and slope. Again, what percent is agriculture, vegetation, surface drainage? How does all that come into play? How does that impact that? And then what are the subsurface flow path characteristics? And so do we have a lot of tile? Most cases in Indiana, at least northern part of the state, central part of the state, tile will be an influencer. And then at the same time, is it actually true tile water, or do we have surface water entering into drainage tile inlets, tile risers, or even tile needs to be repaired into blowholes or suckholes? So that surface water can still impact some of that subsurface drainage. And then what is that surface water used for? And again, where is it ending up at? So think about a few other evaluation tools. You know, we have our various soil erosion, soil health tools that we would use. Some of those provide us a little bit of information related to pest management risks. We would just need to consider those, but we also need to do it for conventional and organic production. So we need to make sure we include both of those. We need to make sure when we're evaluating the water quality risk from pesticide use that we're also thinking about the Windows pesticide screening tool. We've not spent very much time promoting this, talking about WinPST. In most cases, we don't actually utilize it very much, and we rely on TSPs to work that into the pest management plans. We'll talk about that a little bit more as we go along here. But when we do that, we want to make sure that we're looking at both conventional and organic. Any pesticide can be toxic, particularly to non-target species. So it doesn't matter which system we're in. WinPST does a great job of looking at those site-specific risks as far as to aquatic habitat and drinking water. We're thinking about the different loss mechanisms, whether it's runoff, solution, and absorbed, what moves beyond the edge of the field, or whether it happens to be leaching below the root zone. But just trying to look at those three major targets there. So what WinPST does, and we'll go through a little bit here on a little bit more on WinPST. It'll be very WinPST light though, but I want to make sure you're aware of it. It does a real nice job of pulling the soil ratings and the pesticide ratings together to give us an interactions rating. How do those two items combine, and what does that mean for potential losses and then toxicity to fish, humans, others. So, and then with that, it has an exposure, it's adjusted toxicity rating, and it hits down there on that human and fish for leaching and runoff. Here's a report that's printed out of there. Not sure how many of you have seen these before. We'll touch on a couple other reports that we can get out of here. But it will go through, you can select the soils, list the soils, reports will show the soils that were selected, show the pesticide that was chosen, selected in WinPST, and then it goes down and looks at the different loss potentials and tells us if we're at high, intermediate, low, and if there's something there to be concerned with. So, as I mentioned, TSPs are usually the ones who include these within the pest management plan. If after today you want to know a little bit more about this or want to load it, have it loaded on your machine, let me know. So if you did want to install it, there are instructions there. It is in the Software Center. I think it's not something that's commonly loaded now. It used to be included. It's interesting when you go through and install it. Of all places, it shows up in the engineering applications. I don't know why, but that's where it ends up at. In case you have trouble finding it later, search for it. If you have decide you do want it, let me know and I'll try and help with that. But for now, we'll go through and just discuss it a little bit so you have an idea of what's included within that. So when you get into WinPST, you have an option of you'll want to download local soils. These are from soils from examples from Massachusetts. So sorry, I don't have local soils on here. But it does allow you to go through, select the different map units that you want, able to pick out what percentages and how finely you want to break that down. But it brings in all the different background things related to soils, especially as they relate to potential pesticide use. Then you're able to go through and select those. When you select those, the soils drop down here in the bottom into the queue. And then it has all those different parameters on there. And in some cases, you're able to go through and slightly tweak things such as slope or organic matter, some things like that, high water table. If you know that something is present or isn't present, those things are able to be changed, and it will tweak what happens down here with those products or with those soils. Next thing you're able to do is to go through and select pesticides from the nearly, I don't know what, 22,000 plus products. Oh, there we go. Products found, 21,655. And so some of these are, as you can see, Atrazine has a variety of different EPA registrations, labels. Pick the one that's appropriate, and they can, they'll vary just a little bit for a variety of different things, but go through, select the ones that you want. Another thing you're able to do is to, over here into this application area, if it's broadcast or banded or spot sprayed, you're able to select those. I think it defaults to broadcast, but if you know it's banded, then that'll also mean that less product was applied. So as a mitigation, that can be beneficial. Also, surface applied and different things like that, or if it's incorporated. And then once you do that, those products, you select those products, they show up down here in the queue, and then you go through and select a variety of products if you want. And then down here in the bottom right is a reports button. Click on reports, and it pulls up the pesticides, the soils, and then also the interactions reports. You're able to preview, print, or make a PDF out of them. All very useful. And when you do that, in this case, it pulled those 3 reports out. They're sitting here waiting for us to click on to look at. And so in this case, we'll look at the one that has the soil pesticide interaction loss potential and hazard rating for the product, and it goes through and compares the again the pesticide with the various soils, and it gives us the hazard ratings. So actually, PST has been around for a while. Admittedly, haven't used it lately. When I did use it, it was pretty intuitive, and so not too bad. And then when we get those reports out, like I mentioned, then we're able to go down through here and look and see what the human hazards are in the fish hatchery. In particular, when we're trying to identify those resource concerns related to that water quality. So we would think about what those hazards are. So if we went through and utilized WinPST and it was a very low or low final hazard, then that does not require mitigation. At the same time, as is always the case, producers still need to follow the label. And then we're also hopeful, encouraging that integrated pest management is being included. Everything from scouting, identification that the pest is actually out there, correctly identifying the pest, and then doing everything we can to apply those products in good manner and what we can to avoid herbicide-resistant weeds. All that starts to come into play within IPM. But in some cases, we could look at this as, we don't do this very often, admittedly, but other ways that we might be able to help producers understand mitigation requirements. And so, things such as runoff mitigation on insecticide labels, fungicides used to have setbacks for them from environmentally sensitive areas. And then also the herbicide application rates are linked to soil texture. Atrazine label also has some specifics related to the highly erodible requirements. So start thinking, continue to think about preventing and mitigating pesticide risk. We get a final hazard rating in WinPST of intermediate, high, or extra high. then we need to do something to address those water quality concerns. And we've got our conservation practices, avoid, control, trap, how we're going to, which practices we might select for those. Also this prevention, avoidance, monitoring, and suppression, PAMS, is something that's been out there for a while, but that comes into play real nicely with IPM and how we think about especially addressing those pest concerns almost as much, I think, related to prior to pesticide application. And the 4 R's, we think of it more as a nutrient management thing, but there's still the right source, rate, place, and timing of the pesticide that's being used, and seeing what we can to make tweaks or changes within that. So just a few examples. I already mentioned this one a little bit. Scouting and treating only where necessary. We might be able to do partial treatment of a field. Maybe it's just the one part of the field. We don't need to do the whole field. We can substitute for a lower risk pesticide. Trying to avoid applications right before rainfall. Although unfortunately, what's the if this had been spring and we had this rain forecast for yesterday and today, when would have a lot of pesticides gone on? A lot of herbicide applications would have happened right prior to that. So a little bit hazardous there. Two-step IPM process, preventing that risk as much as possible, justifying the pesticide use, the need for that, making sure that there's that economic threshold that it's actually needed, and that we're controlling the pest at the right age of that pest, the right life cycle of that pest. Of course, if we catch it when it's smaller, earlier, have better potential to be able to control that. Think about the various conservation practices, irrigation, water management, how that, if we're putting on extra water, then we have potential of moving pesticides off-site. So trying to time those well together and make sure they work. And obviously some of the buffers can help us out as far as, especially think about that zone of no application. There's numerous times we put a filter strip next to think about open ditches, and we kind of wonder how much filtering does it actually do. Well, in all those cases, we still get that 20 feet, 50 feet zone of no pesticide application. So it's not right near that stream, that ditch. And it happens, the boom swings out around and sprays over the ditch or whatever. So that gives us some benefits there, but also ability to trap some of those products at the edge of the field. So slightly touch on the 595 Pest Management Conservation System, and this has changed names probably 3 or 4 times since I've been at the state office, and so it's but anyways, it's Pest Management Conservation System. The definition there, criteria, again, an IPM plan will be utilized with specific techniques. We've talked about those, the PAMs, the 4 R's of ACT that prevent or mitigate risks to those natural areas. Again, some of those techniques include application timing, and if we've got a big rainstorm predicted, maybe we should avoid applications then, but then also doing things with down here at the bottom, that exceeding IPM thresholds, economic injury, aesthetic injury. If we've got apples, fruits, vegetables, things like that, sometimes, especially being sold in a store or something, there's need to make applications to it for good or bad. Other IPM techniques, I think we see a lot more of the precision application. I know we try and promote this a little bit through CSP. One way is automated boom shutoffs, so we're not overlapping, making double applications at various parts of the field. I know some of those they've talked about being able to reduce, application amounts, 10 to 20% easily, and so that's just 10 to 20% less product out in the environment. So, and also partial treatments are able to do parts of the field banding, utilizing setbacks. Soil incorporation is one way of getting the products in. We know that also unfortunately opens up for soil erosion, but how all those pieces work together, important. Spray nozzle selection, something we don't talk about a lot, but really important. So we get good control. If you've got a plugged nozzle, it's not going to work as well. You're going to see stripes throughout the field of good control and poor or bad control. And then other ways of using various substitution. And so there's a variety of different products that can be used, pesticides that can be used, or different mechanical controls or things like that to help us out and improve our integrated pest management, which would also reduce the potential to move the pesticides off-site. Well, the last things on here, criteria. One of the things we can do is we can work with published IPM integrated pest management recommendations, work with extension specialists, your CCAs, other agrochemical fertilizer dealers, crop consultants, to identify those different pesticides that might be used. And I hope that most of you know that NRCS staff cannot make pesticide recommendations. And I will talk on this a little bit more later. Also, the standard prescribes the minimum mitigation levels for the identified water quality resource concern. So within 595, if you get a pesticide, WinPST final hazard rating, we'll get it for each of those pesticides, and it'll come through, and the soils, those interactions, they'll come through as low or very low, intermediate, high, or extra high. Depending on the hazard rating is as to how much needs to be done for that site. So, if we have low or very low, we're in good shape. No medication required. Oh, that's a nice typo. No mediation required. And then also down there under extra high, we know that we would need to do a little bit more to mitigate that point. So, and then we'll talk a little bit more about those. So within that, the techniques and conservation practices within Agronomy Tech Note 5 goes through and rates all of those, and it gives them in general 5 to 15 points of mitigation credit. And so if you think about leaching as an issue, then if you applied it, if you banded it, then you're applying a third or a quarter less, and so you've probably done something to mitigate the leaching. If runoff was an issue, and now you've put cover crops or reduced till or no till, we've probably done a lot, at least gotten higher points to address that loss potential. Drift is kind of is out there in different products, and we've heard about it with the products are escaping my name now. A lot of issues with that here lately. The Office of Indiana State Chemists has had a lot of investigations related to those, and they've so that's always a potential issue. And then if it's getting into surface water, surface water bodies is a problem. It's one thing if it's getting on someone else's crop. That's obviously an issue too. And then there's also the potential to select, we're giving those different credits, and then the producer can choose to mitigate or use a lower risk alternative. All right, so that was what the national had. I still think there's some items to consider, to think about, and we'll touch on those here in a little bit. But first, a little quiz. So Stephanie, if you want to.
I will launch the first quiz question. It should be coming up on your screens. If you're on a phone and you can't see it, I guess we'll have to troubleshoot that some other way, but hopefully you can see this. Select your answer and then hit the submit button. All right, I'm gonna see how many are coming in. All right. We got about 60 responses in so far, Tony. We're still coming in pretty strong, 75. Overwhelmingly, the responses are coming in as false at about a 70 to 30 range is what it looks like. Most people are responding false. Some people are responding true.
All right, so, and I'll admit, I think this one's a little bit of a tricky question.
So you started out with a trick question, huh?
I did. That's the way it is. WinPST provides planners with a list of the most effective pesticide products well, it doesn't provide us with the most effective. So, but what it does do is it does that comparison. It does that interaction between the pesticide and the soil itself. So the answer on this should be false. So let's move on to the next one.
All right, the next one is launched. It is not necessary to run WinPST for pesticides that are not applied every year. So that's a double negative in there. Oh man, I hate these.
Admittedly, I pulled these off the Ag Learn.
All right, we're getting about 50 responses in.
So even if the pesticide is not applied every year, we still need to would still need to run WinPST on that. So the answer would be false.
Yeah, and most of the responses are correct here. We got about 84% responded as a false.
And I've been able to pull that part of the screen up, so I'm able to see the poll as we're going along.
All right, I'm gonna close that poll. Let me know when you're ready for the next one, Tony.
Let's hit the next one.
Okay. Using WinPST is an EPA requirement.
When EPA does their registration, do they utilize WinPST? Or when a person uses the product, are they required to use WinPST? That is correct. They are not. They do not. So the answer is false.
All right. Let's see here. Looks like one more question, Tony.
Okay, I didn't remember how many we had in there, but that seems about right.
I think it was four of them.
I think you can see them coming up there.
All right, so WinPST's very low, low, intermediate, high, and extra high results indicate the potential for a pesticide to damage the current crop or any crop planted in the same growing season.
So the WinPST results tell us anything about what it's going to do with that current crop or the next crop?
So you can see the results coming in. We got about 70 in. It's about 70, almost 80-20 false. The true responses.
It does not show us that. It shows us the interactive, more specific to the water quality issues related. So
at risk.
All right. So did we think we had? Is there one more? Do we think that's it?
It looks like the next question we have on the list is about integrated pest management and conservation practices.
Oh, I think we did want to do that one now.
No, I think we were going to wait, right? Or yes, do that one now.
Yes, I think do that one now. I think we might have one or two more here.
All right. Integrated pest management and other conservation practices like irrigation water management should be utilized to keep pesticides on target so they can do their job.
Oh, we should have started with that one. That's a gimme. Oh, somebody just clicks false just to help us
Be an
out.
outlier, that's okay.
That's good. That's good.
We
All
got a
right.
good 100+ responses here
All right.
coming in. It's
All right.
going
That's
pretty
good.
crazy.
All right. I
I-
think we do have one more.
All right, you're right. I do think you are correct on that one. So I'm gonna close that poll and I'll launch the last one. Conservation practices like irrigation water management should be utilized after the growing season to help move pesticide residues off the field so they don't damage the next crop.
So this would be where we would use irrigation water management to get rid of all the herbicide residuals so the cover crop would come up. Is that what you're saying?
That's what I'm saying. I keep wondering why we like irrigation water management so much for these questions, but it looks like we got about 100 responses, about 95% in the false camp.
Yeah, very good. All right, so that's correct. We're generally not going to do that to move those products off site. Although in that one situation, I did kind of wonder about that, but I don't think we still want to generally, as a standard operating procedure, want to do that.
All right, we do have one question, Tony. I know you're probably
Oh,
going
yeah.
to
I
bring up
just
a
saw it.
break next. Do you see it?
Yeah, what is the percent of irrigated acres in the state of Indiana? Let me see. I think it's less than. I think it's less than 1 million acres. I'm partly because I was preparing for another training session, and I think I've seen that. I'm pretty sure it's less than 1 million acres. So that'd be less than. That'd be a somewhat our cover crop. I think what I looked at last time, actually, cover crop acres is more than irrigated. Don't quote me on that. I think that's what it is. So.
We won't quote you, Tony, but you are recorded now, having said that.
Oh, that's right. I am, aren't I? All right. Okay. So what we want to do now is take a little break. Let's take a break until 10:30. Yeah, let's do 10:30. Give you a chance, stand up, stretch, grab some coffee, whatever. Um, and then I got some things I just wanted to hit on at the end. Try and move through those pretty quick, and then we'll be done. So back at 10:30, please. Thank you.
All right, thanks, Tony.
right. So I've got 10:30, so we'll get started on this last part. Thanks for a couple people went out and looked. Ag census, ag stats, and looks like around 500,000 acres of irrigated land. And I wouldn't doubt that we'll see a little jump there. And I think we've been seeing that since that, like Carrie mentions, that drought of 2012. So we saw irrigation go in on a lot of places after that we hadn't seen irrigation at in the state before. So thanks for that. So all right, so what I want to do is continue. So what I presented before and laborious. There's a little bit of a challenge when we do these. We try and take an ag learn training and do it for the state, realizing that people move into the state, people move out of the state. So we want to kind of be applicable wherever you're moving to. It could be the state you came from or the state you might go to utilizes WinPST in a different way than Indiana does. So we at least want to cover it in some context and go through some of that. Now what I want to do is hit on a few other things that I think should have been included. And it wasn't, not saying it wasn't completely there, but I didn't see it, and maybe it just didn't fit in the context of how they were thinking about it. We all think about these. You ask a group of people to present on a topic, and you'll end up with a variety of different ways that people would go about it or what they would emphasize and that. So just hit on a few other items here. I think we still want to just make sure that products are being stored, handled, and correctly. I think enough said of that. One thing I don't think was touched on very much or barely mentioned in the training was the potential impacts of soil health and increased soil biology or increase in soil organic matter and how that relates to the pesticides, both as water quality, runoff, how it impacts the whole system in that. So I wanted to touch on that just for a little bit because I think we need to keep that in a context there. So when we think about the water quality, we always talk about conservation cropping systems, soil health management systems, very rightfully so. But a lot of these different things will impact how those products are used and utilized and when they're used. So, we've got the crops out there in the field. We want to make sure we've done everything we can nutrient management wise. pH, timely rates, of those nutrients that are applied. We want a healthy growing crop. A healthy growing crop fends off, wards off disease, insects, and the pressures from weeds around them to some degree. Also, as we promote more cover crops, we know that is a factor as far as how pesticides are used. If we have carryover, that impacts the pesticide. Are we selecting a cover crop to attempt to help us with weed management? Are we putting on a high enough rate of cereal rye, for instance, that we're maybe thinking about that as a weed management tool? We also want to make sure we're thinking about the whole picture of the integrated weed and pest management and how that impacts these systems. We know pest pressures change as we switch from more a conventional system to more of a biological system. Sometimes there's a lag time for the biological control to get ramped up and get going. How do all these things come into play? Make sure we're not forgetting that. Crop rotation, if we're just in a corn rotation, I would call it rotation. But that also comes into play. So we would expect to have different pest pressures related to that. In this piece, and that's one reason why we've included the precision farming technology, because it's it's everything from the precision seeding, but it's also the precision application of nutrients and pesticides. So trying to do those so we're not applying more product out there than we need, and how that also factors into this whole system. Buffers, again, those areas of no application, taking those areas that are less productive out of production, putting them into something more wildlife friendly or something else. But trying to think about all that. But all that comes into play in the water quality. I didn't think that was emphasized very much. So another piece of this, and I touched on it a little bit ago, had to do with NRCS staff cannot make pesticide recommendations. Even if you have a pesticide applicator license, you still are not supposed to be making as a USDA NRCS representative. At the same time, can or should we ostrich this topic? I don't think we should just stick our head in the sand on this piece of it. There are things that we can still do that we still should think about. So weed management. So there's this paper, if we don't think about weed control or herbicide resistant weeds within conservation agricultural systems, what's one of the next recommendations? If we don't have herbicides or we have herbicide resistant weeds, what are we going to do? We're going to do more tillage, right? Well, that takes us backwards on everything else we wanted to do on the previous slide. So that's another reason to really think about how we utilize these products better. We've got the products. There's not a lot more in the pipeline. We hear it from the pesticide companies. It takes a lot to R&D to get these products out to us. How do we make these products last longer? How do we, not get into these resistance? I'm old enough. I remember in the mid '90s when glyphosate was introduced, and I'm really sure we were hinted that would not develop resistance. And here we are. You use a product often enough, if you use it frequently enough and it's not used effectively, we can have issues with that. As I mentioned before, the utilization of cover crops, man, we're doing a great job with that. We still have room to go, but more producers using it, but we've got to figure out how to help them with the termination of those cover crops. The cover crop that fails, in a year, in a season, was that from herbicide carryover from previous? I think we've got a better thought process on that now, but I think we still run into issues with that. I'll just throw a few others out here. Invasive species, trying to attempt to address, within the woodlands and that, trying to make sure, again, we're using these products the best we can, proper weed ID, using the best product for the weed that's identified. And then these others, the pollinators and the monarchs. Products that we're using, that we're getting out here, are having impacts on these things. So what do we do to promote those using more benign products and all that? So I think it all ties together. It's still things that we need to think about, pay attention to. So what can we do? Well, one thing that we can do is we can still utilize cooperative extension service publications. So in this instance, herbicides. The weed control guide, hopefully some of you have seen these, or maybe you have them. I think we've ever bought them, but it's hard because a new one comes out every year. What changes from year to year? Sometimes not very much, but all it takes is adding a different product, the label on the product or whatever else. Sometimes on these, it goes through some really nice descriptions of the weed and how to control it, and that it does a real nice job on that. So there's a source. Also gets into weed control publications like this one in the middle, specific situations, what spring burn down applications are, that they're thinking about for weeds and cover crops. So valuable with that. That also could get as specific as different weeds. So in this case, poison hemlock, one we've had issues with. And with that one then, it pulls up, it has a specific section on control. It tells us that control of poison hemlock with herbicide is most effective when applied to plants in the first year of growth or prior to bolting and flowering the second year. Well, that's, we got a young plant there, usually much better. It goes into much more on that. It goes into talk about the different pesticides that can be used. It doesn't talk about rates. So these are things that we can still utilize, point to, give to someone and say, here's what you need to do to control this. Now, it doesn't have something on there about, use between 6 and 18 ounces. I think the weed control guide gets into some of that. And if it did say 6 to 18 ounces, then we wouldn't want to say, well, yeah, in this case, you might want to use 6. In this case, you might want to use 18. I don't get into a slippery slope, especially when we're trying to do so much with cover crops. But really, if we have a publication that we can point back to, hand to someone, is much better for us, and it is how we can do that. So we think about the weed control and cover crop termination. So this is something I think a little bit about as we're promoting cover crops. I think we also kind of want to think about how the weed control or termination is happening on that farm. Are they having success with it or not? If they already have, and I realize some of this is through time and it's not necessarily a fault to that person. Things spread by aerial and other means, and so those things happen. But there, and I'll use this. I know I've used this example before, but I'll use it again. Years ago, I was invited with the DC, was trying to look at a CRP filter strip. The farmer had trouble with a lot of weeds in the filter strip. So we went out, was looking at the filter strip. And we're looking at the filter strip. And I wasn't sure where the filter strip ended and the field began. There were weeds everywhere. And my first question was, who does the spraying? And the DC said, well, the farmer does the spraying. And I said, I think there's another issue going on here. I think there's a water quality issue. And this was before we even had some of the stuff out there related to this. I think there's something else going on that the farmer doesn't quite understand about the product, the pH or hardness issue in the water or something like that. And so, you know, they need to work with their local extension, or they need to work with another company nearby or something, because there's something else going on there. But in those cases, if we're having trouble with weed control, what cover crops should we use out there? Should we start them with something that winter kills? Or, you know, if we've lost a pesticide product out there, then maybe we should be thinking about that utilization of maybe a cereal rye at a higher C. But at the same time, are they going to be able to get that killed like they need to? So it's a real, I think we just need to think about that, how we're going to do that. And then also, I touched on this a little bit already, integrated weed control and cover crop inclusion termination. And then the herbicide carryover problems for cover crops. We know those have been challenges for us as well. So another thing that we've done through the years, and as you see, you know, some of these things are getting a little bit dated. Some of them seems like it's just barely yesterday when we worked on them, but obviously it was not. But in this case, we put out one on weed control and herbicide-resistant weeds, one of the crib notes. And so within the crib note, one of the things that we tried to do was, you know, emphasize some of those things that we've already talked a little bit about. You know, we want to make sure we properly identify the weed species. There are different amaranth species. You ought to make sure you know what they are. Plant size makes a big difference when you're trying to treat it. If you're trying to spray a weed that is 12, 18, 24 inches tall, oftentimes a herbicide application is only going to piss it off. It's just going to turn brown and it's going to come right back. Might just brown the tops of it and it'll be back. I think this piece on sprayer tank water quality, that hardness, the pH, is in there. I have to think about that. Is there a question? Or the selection of the various proper spray additives, making sure, again, that we use the product to the best ability that we can. And then there's also the thinking about the different environmental conditions when we get ready to apply these products. You know, if it's almost in a drought, or we've, you know, it's real high temperatures or something, sometimes that's not the best time to apply some of these products. And then this other piece down here about using herbicides with different modes of actions and sites of action. You know, if all we're doing is using the same soybean herbicide control from year to year, even though it's every other year, you're only using the same family. you may be creating trouble in your soybean fields, or sometimes there'll be the weeds left over that are going to be in the corn that you're going to have to address. I remember years ago working with a farmer. He was so happy that glyphosate corn was coming on, because all he's going to have to do is spray glyphosate on his corn and his beans. And I thought, oh my gosh, I see an issue. So another thing that we can do, again, utilize those various resources. This is the Field Crops Integrated Pest Management from Purdue. Has a real nice calendar related to various insects. And I believe this one was for corn. There's also one for soybeans. So you can kind of have an idea of what pests might be at that different calendar, different time of the year. You can go through and click on those, and they might have more specific, they will have more specific recommendations related to those. In general, they do have the corn insect control recs and the soybean insect control recs. A little dated, but that's what they have. Then there's also this one that's really good, effectiveness of neonic seed treatments in soybeans. It has that one, a good publication out there as well.
Hey, Tony, this is Stephanie.
Yeah.
There hasn't been any questions into the chat yet that I've been monitoring, but Don did paste into the chat a link to the 2020
Okay.
weed control guide for Ohio, Indiana, and Illinois. And I quick did some searching. The 2021 weed control guide is available as well, but it's $17.25 for a hard copy and $12.50 for a digital PDF. So the 2021 is a free. Well, I think this was a free download. I don't know. Maybe Don had to pay for it last year, but
no, thanks. And that's a good point. Yeah, it is out there on the website, as a lot of these are, especially the extension publications. But unfortunately, that other weed guide, there is a cost to it. If you're lucky, if you go to the right extension meeting, sometimes you can get free ones. So thanks for that. Spider. Is there one? Okay. If this was only an iPhone, it might still be moving, which would be even creepier. But so anyways, have you ever really stopped and looked in a no-till field for spiders? And this is a picture from Terry Taylor's field in Illinois. I mean, I've seen spiders in other fields too. Unfortunately, some of us also got bed bugs on that trip to Illinois. It's a different story. But if you look around, you will see spiders out in these fields. Great biological control. And I love this picture, early morning spider webs on Barry Fisher's cover crop field. Is that cool or what, seeing those spider webs out there? So, a lot of, we know Barry's been in that system for a long time, so he has lots of biological control. Pulled a couple of slides out of a Jonathan Lundgren presentation. He was here, I don't know if you remember, a number of years ago. I haven't looked back on him lately, or what's he doing now. I'm overdue and listening to hear what he has to say now. But when he was here, he talked about these natural enemies, saving farmers billions each year. Again, what do we do to promote them? Seed predators. This is something I not considered. If you took a weed science or entomology class years ago. Some of us, it was longer ago than that, but did the textbook or instructor talk about which insects favored which weed seed? Are you kidding? Which beneficial insects prefers which weed seed? I bet that was not in the thought process, but a little discussion on that sounds pretty cool, pretty interesting to me. We know we've had this issue about neonicotinoids. Are they helping or hurting? We know it's very commonly used on corn and bean seed. What we've seen is in many cases in beans, it's not needed. It doesn't control the pest insects. It's almost unavailable by the time the pests actually are kicking into gear. They're also water soluble. They kill the natural enemies. They probably don't do much for our soil health, and they cost $10 to $15 per acre. So anyways, just a factor related to the neonics. And then another great publication, title isn't what you think it might be, but the effects of neonics on ag does a real nice job of going through and talking about those. And this, even though that's a little bit dated now, that's a really nice publication. And on some of these references I'm throwing out there, sorry I don't have direct links, and if there's something you're like, you know, what is that? Where's that at? Let me know, and I can either send you a copy or send you a link or whatever, and we'll do that. So I think a little bit about kind of winding down here, a little bit on these pesticide resistance issues. And I think we need to think about this a little bit. So we have the pesticide label. They've been out there for a while. It's what everyone's supposed to be following. Everyone who applies pesticides needs to be licensed, whether it's private or commercial. Those individuals are required to attend training sessions, receive continuing credit hours. We also have various pesticides that are restricted use and have additional special requirements related to them. We have more technology and GMOs than any previous time in history. Duh. Haven't done that in a long time ago. But we have all this that's available. And yet we continue to have these issues with resistance. You know, one that I think about is, have you ever heard of an insecticide being added with the fungicide application? Well, I unfortunately hear that kind of commonly. Well, we're making the fungicide application, so we'll just throw in the insecticide just in case. Well, we kind of question the fungicide application as well. And now we're throwing insecticide in just in case. I really think we need to think about some of those things a little bit. And yet we still have some people continue to wonder why we have increased resistance to pesticides. So just some challenges that we have. These aren't directly related to us, but I think having these in the background and encouraging pesticides to be utilized differently keeps these products available for us when we need them. And when we need them, we want them there for us. We want to be able to utilize them. So it's one of those things that we hope when there's an issue, we may be using one of the a more hazardous pesticide to control the issue at hand. But if there's not much of an issue, then either we don't need as much or we can use a lower risk pesticide, either way. So another piece of that, kind of finishing up here, a few references. You know, partly I don't know what you're interested in. I don't know what you think your various producers, farmers are interested in, what you want to have available at a field day or a handout or in your office or whatever. But so try and make a variety of these available, but just mostly then we have to let you know where they're at. So we've updated, revamped our conservation conservation cropping systems website. Got this piece on there on integrated pest and weed management, a variety of different resources. One of those resources, one that we developed a few years ago, Agronomy technical note, especially for people making the transition from a more of a conventional to a high residue system. This might not be for the person who's been in a high residue planting system for a long time, but there's probably still some things in there. But we've tried to go through and include, tips and things that could be on there. Tried to work with Purdue on some of those. So, tried to work with Bill Johnson on this, and worked with Krupke and Obermeyer on the pest management, and worked with the new disease person at Purdue on the disease, on the pathology part. So, but anyways, a variety of references there. All right, Stephanie, I think we're ready for those last quiz questions, and then to see if there's any other questions. So.
All right, Tony, I'll pop the next, I'll launch the next poll into the meeting. Again, not sure if you can see him this time, Tony, or not. Okay, it hasn't popped up yet. Don't panic, anyone. It just went live now. It was thinking.
It's interesting. It shows up differently for me this time, not across the screen, but over in the. It showed up in the chat this time.
They always show up in the chat. So
okay, that's fine.
So like what I'm doing is I'll have like your presentation or the meeting open, and then I have that on one screen, or actually I just have a large screen, so I have my screen split with that, and then the chat on the other side, so I can see both. And in the chat, I can see the responses coming up.
So last time we were doing it, it was popping right up in the middle of the screen for me. So okay, that's fine. Nope.
There we go. So we have about 100 and close to 110 responses. Most of them, about 90% of the responses, are all of the above, that the word pesticide refers to insecticides, fungicides, miticides, herbicides.
Yep,
and there are a few people that are mentioning A and C, but what is the correct answer, Tony?
Correct answer is all of the above. All right, number next.
All right, launching it now.
Oh, now it showed up in the middle. Okay.
IPM, you got it, Tony?
Go ahead.
IPM utilizes damage thresholds for making pesticide use decisions in order to reduce environmental risk. We're getting some pretty quick responses today. This is nice to see that this is working for attendees. That the question can pop up and people can respond quickly. So that's good.
Good time to test it too. So. All right. So yeah, that's right. So IPM does utilizes those thresholds to help us make better decisions, and as we're doing that, we'll hopefully reduce environmental risk. So, correct. That is true.
I'm launching the next one, Tony, if that's okay. Mm-hmm. Integrated pest management utilizes damage thresholds for making pesticides use decisions in order to provide economic benefits to the producer. I paused there a second because all of a sudden I was concerned that I had relaunched the same poll as previous.
It's very similar, yes.
But the other one was environmental risk, and this is economic benefit.
Yeah, a little trickier on the wording. Might require a second read on that. But yeah, we hope that within IPM, we are utilizing economic thresholds, damage thresholds to help with decisions. You know, I didn't talk about it, but you know, there's times like a armyworm or something. You know, it might be where we see armyworm out in the field, we're getting ready, we need to go out and spray it, you go out and do some scouting, you realize that you start looking at that armyworm, and on them, they've got some little white bumps on them. And those little white bumps are a parasitic wasp that has come along and laid eggs on that. And that armyworm is being cannibalized on the inside. It doesn't quite realize it yet, but that armyworm is on the way out. We don't need to spray that one. And so then you're trying to look at the whole, well, what percent of the field is that? And if you've got that type of pest control out there, a biological control for that pest, then maybe you don't need to spray at all. So.
All right, I'm launching the next question. This is the second to last question, I believe. Organic agriculture doesn't need IPM because the organic pesticides are safe.
And that's right. We're hoping to utilize integrated pest management for all crop production. There's places for all of it. How do we make sure we're doing better with that, the scouting and everything else? And so I barely touched on it, but how do we get fence rows and field borders and other things into play for beneficial insects, not just within the field, but on those borders, those edges. Didn't even touch on bat or bird populations. There are some cases where we've wondered about trying to increase populations of those and what that might do as well.
It seems like the false response there could pertain to the IPM not needing IPM, or to the organic pesticides being safe. It's kind of interesting to think about that from a dual perspective.
Yeah, right. Yeah, it's a little. A lot of these you read, and they're like, it's a little tricky. Depends how you want to read it.
All right, I will launch the last question. IPM manages pest resistance to help maintain pesticide effectiveness. As this last question is being answered, Tony, I think that these last few questions that we went through really help cement in people's minds maybe the role that IPM plays in the ever diverse and strategic role that integrated pest management plays in our cropping systems.
Yeah, and I think that's one of the things that I kind of want to leave it at is, we even though we don't get involved in making the pesticide recommendations per se, we still have, I think, an important place in this. We should have some thought processes on how pest management, integrated pest management, impacts the various conservation practices, the things that we want to get implemented on the field, but what impacts those have on those other big picture items. The soil health, water quality, air quality, everything else that we work on. I think there's a real piece in there that comes in, and are we necessarily going to get a producer to quit using a pesticide? No, I don't think that's the case. Can we try it and help them think about using the product in a better way or better? Yes, hopefully that is able to do that. So. But yeah, we want to try and utilize those that IPM, for the to manage the pest resistance, so that we reduce the potential of that pest resistance. So that answer is true. Let me see, Stephanie. There were some other comments came in on the questions. I was just going to look back real quick.
I got to scroll back up past the poll questions. Jennifer Kipper put a link in there for SICM website for some information about an invasive plant control calendar of control. So a good handout for people.
I got it. So yeah, that's right. And so there are other tools out there, and that's really good. Thanks for Jennifer for adding that in there. And then also, again, we're trying to do what we can to promote the control of these different weeds, SICM and other things, or so always just trying to pass those things on to other people and make others aware of them is very beneficial. So if you have other thoughts, ideas on that, please do. All right, so with that, I think that's all I had. Appreciate everyone's time. If you have other questions related to anything here, if you want more detail on something, please holler, and otherwise we'll give you the rest of your day back, and have a great rest of the week. And hopefully we'll see some of you more later. Thank you very much.